Dear friends, we are going to analyze a more important and useful topics of science, engineering and mathematics, that is tensor analysis. And you will be surprised and at the same time will be excited to know that we are preparing ourselves to study the physical laws or the physical phenomena in a more general way. And some of the physical laws we have studied earlier in our previous classes, and some of them we will study in our advanced courses. Now, let me take some example or let me analyze some basic things so that you can understand what I mean about the general way of studying. Okay. So, from our childhood, we have studied about physical quantities, and always we like to study physical quantities by categorize them into two classes. One is scalar quantities and another one is vector quantities. And the scalar quantities has magnitude only, whereas these vector quantities have magnitude, direction, as well as it follows the rules of vector algebra, like parallelogram law, triangle law, etc. Okay. Now, again you will be surprised to know that this is not the general case. Actually, this scalar and this vector quantity are the special case of tensor, and there is something called rank. We will study about this rank later on in the upcoming classes. But when the rank of a tensor quantity is 0, then we call it as scalar quantity. And when the rank of this scalar quantity, the rank of the tensor quantity is 1, then we will call it as vector quantity. So, you can understand or you can realize that what I mean to say about the general way of study, why the tensor analysis is very useful to study the physics, mathematics, engineering, everything in more general way. Now, if we talk about the physical laws, that is the physical equation that is arises in various branches in physics and engineering, to understand the how we can study in more general way the laws of physics, let me take two famous example, and these are the very well known equations which are arised in mechanics as well as in electricity and magnetism. And these two basic laws are, one is the Newton's equation of motion, and another one is the well known Ohm's law. And the mathematical form of this Newton's equation of motion is, as you know, F equals to mass into acceleration, or you can say it as A is equals to 1 over m into F. Similarly, Ohm's law can be written as J equals to sigma E. And you know, these are the very basic things, the symbols have the usual meaning. So now, we will be again surprised to know that these two famous equation is only applicable to isotropic medium. What? It is only applicable to isotropic medium. Now, what do you actually mean by this isotropic medium? This is a medium where the physical properties of the medium, is same in all directions. That is, if you go any direction from this point, in any direction from this point, you will feel same environment in terms of the possible physical parameters or the possible physical properties. But for the anisotropic medium, and in reality, there is a lot of anisotropic medium where these physical laws or this equation J equals to sigma E and F equals to m have to modify it. And in that case, we need to write down this J equals to sigma E in this following form, that is Jx, I think I have to write uppercase, Jx is equals to sigma xx ex plus sigma xy ey plus sigma xz ez. Jy is equals to sigma yx ex plus sigma yy ey plus sigma yz ez. Jz is equals to sigma zx ex plus sigma zy ey plus sigma zz ez. So this is the component form in terms of x, y and j, and these are the components of current density vector j, and these are the component of electric field vectors in the direction x, y and z. So here this sigma xs, sigma xy, sigma xz can be written in terms of sigma ij, where I and j denote for x, y and z, and we can write it as j is equals to sigma ij into this can be written as actually sigma ij. I don't want to write down this in this pattern. I will write it in various different cases later on. But now it is sufficient to say that this is sigma ij and this is called conductivity tensor. Similarly, this A equals to 1 over m into F have to be modified, and it can be written as 1 by m in the form of 1 by m ij, and this is called reciprocal mass tensor. Okay, and this is arises when you talk about the conduction of electron in solid, and there we speak to effective mass tensor. So in this way we will use the tensor analysis to study the physical laws in more general way, and moreover this tensor analysis has a wide use in various branches like general theory of relativity, differential geometry, hydrodynamics, and in numerous branches of science and engineering. Okay, so in the next class I will discuss about more about tensor analysis. So for today, thank you.